Hello, and welcome to lesson 10.2 on the properties of logarithms. So, in this video, I'm going to work some examples using these properties. I'm not really going to explain a whole lot where they come from or blah, blah, blah. I'd rather save that maybe for class or for your own enjoyment outside of class, yeah? So we could talk about why these rules exist some other time. This video is just getting familiar with the rules and using them to solve, well, not even really solve problems, just using them, having fun with them, just playing around. So I've got this front worksheet right here, not worksheet, kind of cheat sheet, rule sheet of all the properties you need to know. This top part, you should already know. We've already talked about exponents. This is the exact same top part I gave in Unit 7 when we did rational exponents. So this is the exact same. You should know all of these rules, and I don't need to talk about them, okay? You should know all of them. But I have it here in case you need a reminder. Now for the logarithm rules. I'm going to quickly explain each one, but very quickly, okay? Do note that, again, our base is going to be a positive number that's not 1. Keep that in mind, okay? If I say log base 1 of something, that's not really going to evaluate to anything, or maybe you can think about what that is. Especially if I said log base of a negative number, maybe think about that. Think about what that means, and you'll find the conundrum. So, sorry, I'm coughing. Looking at log of 1, I say log base b of 1 equals 0. That is the rule. That is what's to know. And this makes sense because I'll actually go to this next page here. We've talked about in class converting between logarithmic and exponential. A lot of these rules follow from exponential properties and then just kind of using that with this log rule of how we've defined it. So, you know, b to the x to the a, right, is b to the x to the a. There it is. So if you look at this rule, this says that b to the 0 equals 1. Duh, right? That's self-evident. If this one, you say b to the 1 equals b. Yeah, it does. The product rule, the quotient rule, and the power rule, those might be ones where we really want to talk about them because they're kind of fun to prove. It's really fun to prove these things and why they're true. I'm not going to do that here. I don't think it's that bad. It's not too complicated, but they are right here. I'd put a star next to all three of these because these are the three you really need to know. We're going to use these a lot when solving. Number raised to a log, well, this is also pretty self-evident. It kind of looks goofy, but if you convert this back to exponential form, like if you just use, b to the x equals a becomes log base b of a equals x, right? If you just use that, you find that log base b of x equals log base b of x. You find that, and of course that's true. So, easy. True. The equality rule just says that if two logarithms are equal, and they have the same base, then the arguments are equal. When I say argument, I mean the input into the logarithm. So if log base b of a equals log base b of c, then a and c have to be the same value. Lastly is the change of base rule, and honestly, I still haven't decided how much we're going to use this. We may use it a little bit. The change of base rule was actually, it was needed a lot prior to the current century, just because our calculators of old only worked in base 10 or base E, Euler's constant. They weren't really able to do like log base of a half. But our calculators can actually do that now. So I'm not going to say that this is obsolete. No. It's not. It's useful still. But we probably aren't going to use this rule a whole lot, at least not right now. Okay, you might use it in pre-cal or something often, but I don't know. If you wanna check it out, there's the rule. Okay, let me stop yammering about this and actually work some examples. I want this video to be short. I don't want to talk too long. So I said definitely memorize these three from the table, so make sure you're looking at those. And this practice is just to help you understand how to use the rules. We're going to use these rules to solve in the next lesson. We're not going to solve yet. Solving really is just a couple more steps. It's not actually that much big of a leap, but I want you to get familiar with the properties first, then we'll use them to actually solve some equations. In this lesson, we're going to practice expanding and simplifying these logarithmic expressions. Sometimes when it's simplified like this right here, that's simplified because it's a single logarithmic expression. Sometimes we like that. Sometimes it's a nice answer, or we use it for something. Maybe it's a nice graph. Sometimes, however, we'd like to expand the logarithms. And that can kind of come into play in calculus. Maybe when you are taking an integral of something, you might like to expand the logarithm because it breaks it apart into easier pieces. So expanded form and fully simplified both have their uses, and we're just going to practice going back and forth between the two. Okay, so example 1, it's going to use these three rules here. If you need to pause the video and look at those three rules, do so. It just says that when you multiply the arguments, you can split this into a sum of the logs. If you take a quotient of the arguments, you do a difference of the logs. And then this one's called the power rule. You essentially, if you have log base b of m to the n, you can take that n and you can put it out in front as a coefficient. That says n times log base b of m. That's what that says. Okay? So let's look. Let's expand this logarithm. So I see that this says x times y divided by 3 in the denominator. So we're going to be doing the product rule and the quotient rule, okay? So you can think of it like this. You say, okay, well, I don't want black. I want red. Red, please. So think of it as log base 3. Well, if you consider the product x times y as a single thing, and then 3 is in the denominator, then I'd split this into log of xy minus log base 3 of 3. Okay? This is using the quotient rule, right? Because this is the numerator and that's the denominator. So I just split them up like that. But then this is x times y. So you can actually expand that further because since it's x times y, we say that this is log base 3 of x plus log base 3 of y. Because that's what the product rule says. That is quite literally what this rule right here suggests. Okay? And now I've got this minus log base 3 of 3. But hey, guess what? Log base 3 of 3. If you look back over here, when I have log base b of b, when the base is the same as the argument, it yields 1, okay? The output is 1. So this log base 3 of 3 is actually just 1. This is just minus 1. And that's it. That's it. You've expanded it, okay? We're done. Okay, I might say, here, look, this fella equals 1. Done. Okay? All right, let's move to the next one. Let's expand natural log of 2 times e to the power of 3. So you see this is natural log of 2 times e cubed. Well, using the product rule, I can write this as a sum of the natural log of 2 plus natural log of e cubed. Now, the nice thing about this, so natural log of e cubed, you can actually simplify this further. It's actually going to be 3, and let me show you why. Look at that exponent on e, right? I'm going to use, what's wrong with my voice? I'm so sorry. I'm going to use the power rule here. The power rule says, look, if you look at it, right, if I have m to the n, I can take that exponent in and drag it to the front as a coefficient. So I'm going to use that here. I'm going to say plus 3 natural log e. But hey, what is natural log e? Natural log e is log base e of e. And that is exactly what we just did. That's equal to 1, right? Because we did that log base 3 of 3. So therefore, this expands into natural log of 2 plus 3. And that is fully expanded. And it's kind of funny. In some way, we're also simplifying, right? This is, in a way, more simpler than the previous one. Particularly if we were in calculus and we wanted to integrate, this would be a lot easier to integrate. It's actually just a constant value, so it'd be really, really easy. There's not even variables in there. Who cares what that means? We're not in calculus. We're in Algebra 2. Okay, example 3, let's simplify the logarithm. And when I say simplify, I really just mean condense it into a single log, okay? First thing I'm going to use is the power rule, and this goes backwards. I'm going to take the exponent and put it, or take the coefficient, make it an exponent on the argument. So you see this is equal to log of x to the 4. I like to put parentheses around my logs. You don't have to, but unless the argument is complicated, then you need to. But if it's a single variable, you usually don't have to, but I like to always have them. Minus log base, you see this is 2y quantity cubed. That cube is actually going to apply to the 2 and to the y, so we've got to be careful with that. And then, of course, this is just log base 10 of z. Okay, well, real quick, just so I can see this expansion here, that cube is going to apply to the 2 and the y, so that's actually 8y cubed, and then plus log z. Now, if you want to condense this into a single logarithm, well, you multiply the sums, and then you divide the difference, if that makes sense. But you're using product rule and quotient rule at the same time, okay? You can do all three in one fell swoop. I say log of, it's x to the 4th is going to be on the top, and then you're going to have 8y cubed in the bottom, because that's the quotient part. But then it says plus log z. Well, that's just going to go back up on top with x. This is being multiplied with x. And that's it. You have put together the log. I'm really not sure how else to explain it. I don't know if I'm the best at explaining this. You're just using the rules. You're just using the rules. And if you're not sure what's going on, just stare at these until they make sense. Okay? Stare at those until you make sense of what's going on in this example. Okay, a few more examples, and then I will be done. Let's simplify this logarithm. I say log base, okay, so again, base 10. Log of root 5 minus log of root 5 over 5. Well, let's have fun with this. This is, I'm going to show you two ways. You're going to like the first method a lot more than the second method, but whatever. I'm going to show you two ways. So this is log of root 5 minus, and if I use the quotient rule here, this is, well, I'm going to use a bracket because you are subtracting log of root 5 over 5. So I'm going to put a bracket there so that the subtraction sign doesn't get lost. This is log of root 5 minus log of 5. See that? That's the quotient rule in action. But I got to put parentheses or brackets. I use brackets here just because, I don't know, it's a bigger expression. And you use parentheses, brackets, I don't care. And that's just using quotient rule right there. Now, if you distribute that negative, I get log of root 5 minus log of root 5 plus log of 5. So you see these cancel out, right? And that just equals, this is just log 5. And you are done. Simplified. I'm going to show you method 2, though. Method 2 is more complicated, but I kind of like it. It's kind of cool. We could use our power rules here and rules of exponents to help out a little bit. You see, this is log of 5 to the 1/2 minus log of, this is 5 to the 1/2 over 5 to the 1, which means this is actually equal to log of 5 to the 1/2, I'm not touching that one, minus, and then if you do your subtraction rule here for exponents, that's log of 5 to the negative 1/2, right? Because 1/2 on top and then minus 1, so it's negative 1/2. And then you could just use the power rule to say that this is 1/2 log of 5 minus negative 1/2 log of 5, which is really just 1/2 log 5 plus 1/2 log 5. And 1/2 plus 1/2 is a whole, so it's 1, so it's equal to log 5. And that is a second way. We didn't really use the quotient rule here. We used some properties of exponents and the power rule to manipulate this. So, you can see sometimes you have more than just one approach for evaluating these things. Exponential logs, they're all connected, okay? Again, you might like what I wrote and read a little bit more. I don't really care. As long as you get to the right answer, have freedom with this, okay? Have freedom. Do fun things with it. Take ownership. Have fun with it. Okay. Example 5. Let's evaluate this expression. Look, anytime you see a coefficient in front of a log, it's probably a good idea to play around with that coefficient as an exponent on the argument. Meaning, use the power rule. 7 log base 8 of 2 becomes log base 8 of 2 to the 7. Okay? That's what that is. And then I say minus, and then I'm going to use power rule again, log base 8 of 4 to the power of 2. Yeah, okay. And so now if I put these two together, I say, okay, this is log base 8 of quotient rule. Put them into a single logarithm because it's minus, right? So you can make it 2 to the power of 7 over 4 squared. And now we just need to evaluate what that is. Well, 2 to the power of 7 and 4 is 2 squared. So this is actually 2 squared, believe it or not. So that's actually log base 8 of 2 to the power of 7 over, what did I do? Multiply them, right? I say 2 to the power of 4 here. And so now if I use my exponent rules, I'm going to subtract, this is log base 8. You see this is 2 to the power of 7 minus 4. I'm going to just write that out so you can really see it. What is Mr. Spig doing here? This is an exponent rule, by the way. That's not a log rule, that's exponents. Equals log base 8 of 2 cubed. But of course, what is 2 cubed, guys? This equals log base 8 of 8. And what do we know about log base 8 of 8? If the argument is the same as the base, it evaluates to 1. And we're done. 1. So isn't that funny? This whole complicated expression ended up just being equivalent to 1. And there you go. So notice how I'm using multiple properties of exponents in tandem with these new properties of logs. So you got to know both. You got to remember your properties of exponents and your properties of logs. I'm not going to really retread exponents, though. If you need help with that, go ask a teacher or Google it or go watch the videos that I already have on it. Okay? Okay. Example 6, and we're done. I want to keep this video short for you guys. I'm so sorry. Rewrite the expression as a single logarithm. Sure thing. Now this looks tricky because I have a constant -2 here. By the way, it is not log base 5 of 8. You can't just subtract like that, okay? That's not how that works. So how could I play around with this? Well, log base 2, let's say log base 5 of 5 equals 1, right? That's true. So then 2 log base 5 of 5 equals 2 times 1 equals 2. So therefore, I can do a sort of substitution here. I can say log base 5 of 10 minus 2 is actually equal to log base 5 of 10 minus, you see 2 is actually equivalent to 2 log base 5 of 5. Yeah. I'll put parentheses here to be consistent. Whoop, whoop, whoop. And now, brain fart, sorry, Mr. Spake's thinking. Use the power rule, put the 2 as an exponent. So say log base 5 of 5 squared. So that says 25, right? So this is actually log base 5 of 10 minus log base 5 of 25. And since I'm doing a subtraction here, that's quotient rule. That's log base 5 of 10 divided by 25. Which, of course, 10 divided by 25 is 2/5. 2/5. And that is a nice single logarithmic expression. I'm going to box that. All right. And so I've combined log base 5 of 10 minus 2. This is actually equivalent to log base 5 of 2/5. You might say, why did we even bother doing that? Why? Why do that? I don't know. For fun. I told you, log is just fun. We're just having fun with this stuff. We're just playing around with it. I said, what if this was a single logarithm? Well, there you go. That's what it is. Isn't that fun? I think so. Okay. Well, that ends the video. Hope you enjoyed. Let me know if you have questions. This should be enough to get you started on that homework 10.2. Have a good rest of your night, and thanks for watching.